Hi everybody, today we're going to talk about gas laws and stoichiometry. So in a lot of the chapters that we're going to be working on in the future, we are going to link stoichiometry to them. And so one of these chapters is gases. So we learned how to do calculations in chemical reactions, which is what stoichiometry is. We learned about gas laws, and the main gas law is the ideal gas law, which is PV equals nRT. So to link between the two, this is PV equals nRT. This one is calculations and reactions, and the main part of it is having these molar ratios. And so the link between them is going to be moles. So one of two things. Either we're going to use PV equals nRT first to solve for moles, and then once we solve for the moles, then we can use those moles to get something else using stoich calculations. Or we're going to do stoich calculations to find moles of something and then convert it to moles of a gas and then plug it into here to either find its volume or its pressure or its temperature. Just remember that with stoich you can use any substance as long as the substances are related in a chemical equation. You can use the coefficients as your molar ratio. But with PV equals nRT, that's the ideal gas law. So you can only use PV equals nRT if you have a gas. So you can't use it for solids, liquids, or solutions. So let's take a look at an example. So the first example says, what mass of NaCl could be produced from excess sodium and 10 liters of chlorine gas at 23 Celsius and 1.02 atm? So the first thing you would want to do, since we're talking about a chemical reaction happening here, it's not just one gas by itself. So that means we need to write the chemical equation. So let's start with that. So NaCl could be produced, so NaCl comes after the arrow. From sodium, so sodium is one of my reactants and chlorine is my other reactant. Remember that chlorine is diatomic, so Cl2. And to balance it, we need to Na plus Cl2 yields to NaCl. Then I like to write down what I have, so I'm going to do that. I'm given, let's see, 10 liters of chlorine. And I'm also given a temperature and a pressure. Now we know that sodium is a solid at room temperature. It's one of the metals. NaCl is an ionic substance, so we also know that it's solid at room temperature. Chlorine is the only gas that we have there. And so whenever you're given temperature and pressure, those are only relevant for the gas. So if you want to write them on the side, you can, but I like to write my temperature and pressure underneath the gas because that's when it's relevant. So I'm going to write 1.02 atm. And I have 23 Celsius, so I'm going to convert that to Kelvin right away because I can only do calculations for gases with Kelvin. So 296 Kelvin. And then I'm asked what mass of sodium chloride are we going to produce. Okay, so the goal is to find the mass of the NaCl. We don't have any information about NaCl. The only substance that we really have information about is the chlorine. So to link between one substance and another, we have to use moles. And so that's the link there is moles. So whenever you're doing any stoich problem, whether it has to do with gases or solutions or heat or anything, the first thing you want to do is you want to find moles of the substance you have information about. In this case, it would be the chlorine. Then you want to find the moles of the substance that you are interested in, which in this case would be the NaCl. And then you want to answer the question, which is the grams of the NaCl. So first find moles of substance you have information about, then moles of substance you're interested in, and then answer the question. I'm going to write those down. I think it's important that you write them down as well.